Hello students, welcome to today's lecture. So earlier we studied cake filtration, okay? Then we derived the equations for constant rate filtration and constant pressure filtration, right? Now today we are going to derive the same equations, taking care of the resistance of the cake and the filter medium, okay, or cloth. Okay, so this is the general equation, right? So now, since we have cloth and cake combined, so we have to take the total pressure drop, delta P, of through the cloth as well as the cake. Okay. So this is the general equation. Then you can rearrange this. So this looks dv by dt. Okay. Fine. And you can rearrange this like this. Okay. Now, if you integrate this equation from t equal to 0 and v is equal to 0 to t1 v is equal to v1, this is for constant rate filtration. So the volume of filtrate collected after time t1 will be v1. That means it has constant rate filtration. Okay. So if you integrate this equation from limits this from at t is equal to 0, v is equal to 0, and t is equal to t1, v is equal to v1, that is the volume of the filtrate, then you'll get the equation for the constant rate filtration. So if you integrate this equation within this limits, you'll get this equation. Okay. So t1, v1 is constant. So you can rearrange this, right? So you'll get this. Okay. And if you integrate this equation from the limits t is equal to t1, the volume of filtrate collected is v1, and at any time t and the volume of filtrate collected v, that is for constant pressure filtration. So if you integrate this equation at constant pressure, then you'll get something like this. Okay, and you can rearrange this. So as you can see, this is the y. This will be the variable, dependent variable on this independent variable. So if you plot, then you'll get a straight line. So if you plot t minus t1 versus v minus v1 on the y-axis and v minus v1 on the x-axis, then you'll get the straight line. Okay, with a slope of equal this. This is the slope. So you get a slope equal to this, and intercept equal to sum of these two. Okay, this will be intercept. So you can predict the resistance of the cake and the filter cloth. Okay, so here the L is the thickness of the cloth. Okay, so this is all the same thing. Okay, so it is trying to fit the experimental values to a straight line by plotting this versus this. So you'll get intercept here and the slope. From slope you can calculate this value. For intercept you can get this some of these values. Okay, now this was for incompressible cake. So for incompressible cake, the cake does not depend upon the pressure. Okay, but here for compressible cakes, it depends upon the pressure. So we discussed earlier. So to obtain the equation for the compressible filter cakes, you have to rewrite that equation, earlier equation, like this. Because now the pressure is a function of the this distance, okay, from surface of the cake to the bottom of the cake. Okay, the pressure to the cake will be a function of Z, because this cake is compressible now. Okay, so you can do the integration, and so they have done here. So if you write the Z in terms of volume, so you'll get something like this. Okay, where Rz is equal to this. So if you integrate this equation again, you'll get the linear line between V and T. Okay, so you can calculate the resistance of the cake as well as the filter cloth. Okay. So you can see the resistance varies like this for compressible cakes. So this raised to the power n dash, and n dash lies between 0 and 1. Okay. So we'll solve equations in next classes, so that we get a clear idea of how to solve this kind of problems. Okay.